let's take a look at Chapter 5, Section 6, where we are going to graph inequalities with two variables, okay? This is going to seem really familiar, so hopefully, hopefully it seems familiar. We're going to use some words with planes and boundary lines and things like that, but basically the rules to doing this are the same as the rules to graphing lines, just with some slight additions, okay? So let's take a look. All right, so first there's some steps here. Let's scroll down and take a look at the steps. So step one is we're going to graph the boundary. So that's the line itself, okay? Key information here is that when we have an equal than, less than equal to, greater than or equal to underneath, that the line is solid, and when it's not, the line is dashed. Okay, so that's a big key. Then we're going to use a test point. So that's step one. So graph the line. Okay, graph line. Step two is to test. We're going to test where we shade. Because it's an inequality, it's either going to be everything above or below, depending on your perspective, the line. So we're going to use what's called a test point to shade. I'll show you how to pick that. And then we're going to shade the correct half, and then that's it. Okay, but graphing the line is the hard part for some of us. So if you don't have graph paper, you may want graph paper. All right, so take a look at this example. We're going to graph 3x minus y is less than 2. First, we're going to get y by itself, so that's a key. On this one, we get y by itself, and then we graph that. So we have y, and we just graph y equals with the understanding that because it's less than or greater than right here, and that the line is dashed. Okay, but we graph it the same way we graph any line. So negative 2 is the y-intercept, and then up 3 over 1, up 3 over 1, and that's how we get our line. So that's step one. Step two is a test point. The easiest test point in the world to pick is the origin. You only can't pick that when the line goes through it. But if it doesn't go through the origin, then picking 0, 0 is the best thing you can do each time. So you plug 0 in for x, 0 for y, and you see what you get. If you get a statement that is true, then you shade that side. Okay, because we got a true statement, that means the origin is a part of the answer. So that's the side we shade. And that's it. Okay, so you graph the line, you pick a test point. Again, the origin is the easiest test point to pick. And then if it's true, let's bring a graph over here. If it's true, then that's the side you shade. If it's false, you shade the other side. Pretty easy. So let's take a look at this one. We'll do this one together, and you can do 1b on your own. So first, let's graph the line. So we have the y-intercept is 3. The slope is up 1 over 2, rise over run. So here's our line. Okay, I noticed that it's just greater than. It's not greater than or equal to, so my line is going to be dashed. Okay, my line is going to be dashed. So let's see. That is slightly off. That's better. All right, so there's that. Then I'm going to choose my test point right here of 0, 0. So I put 0 in. Hold on, we're thinking. 0 is greater than 1/2 times 0 is 0 plus 3. So I have 0 is greater than 3. Well, that's not true. So that means that this side where my test point is on is not the true side. So then I shade the other side. Okay, so I have my inequality drawn. I have it graphed. Okay, I pick a test point and I shade the correct side. And that's it. Okay. Important that our lines go completely across the graph so that it's shaded correctly, but that's it. Go ahead and pause the video here, see if you can solve or graph 1b. Pause the video now. Okay, I'm going to walk you through 1b. The first thing I did is I rewrote it so that it was 1 is less than x minus 1. Now my y-intercept is negative 1, and my slope is 1, so that's up 1 over 1. So there's my line, or there's my points. Let's get my line back. My line is dashed because it's just less than. Okay, and then I'm going to pick my test point of 0, 0. Let's see, I have 0 is less than 0 minus 1. That would be 0 is less than negative 1. That's not true again, so I shade the other side. So I'm going to shade down here. That's everything beneath it. And that's it. Okay, I'm going to make sure I do, I don't have to do like the world's greatest job shading, but I want to do good enough so that my teacher can tell what I'm shading. But that's it. Okay. Take a look here. Same exact rules if it's greater than or equal to or less than or equal to. We solve for y, so you got to get y by itself. So that can get harder depending on the problem. All right, so here we end up with y is less than or equal to negative 1/5 x plus 2. We graph that. The line is solid. We choose a test point and we shade. Again, same concepts. And no big deal as far as long as we can get the y by itself and all that. So let's take a look at 2a and 2b. All right, so let's look at graphing each one of these. The first one, again, the first thing we're going to want to do is we're going to want to get them both into a more y equals mx plus b kind of slope-intercept kind of setup here. So if we add y to both sides and subtract 3 from both sides, we get y is greater than or equal to x minus 3. Our y-intercept here is negative 3. Our slope is 1. So there's that. Let's get our line drawn. Our line is going to look like this. We'll just extend that down. Then we choose our test point. So our test point, I'm going to choose 0, 0. We can just plug it right back into the original. So we have 0 is less than or equal to 3. That's true. Because that's true, that means our test point was true. That's on the true side. So we would shade everything up here. Okay, and that's it. That's all you got to do. The hard part, picking the test point and plugging it in correctly, and then maybe manipulating the equation. This one's a little bit more work to manipulate, so we end up with 3y is greater than or equal to negative 2x plus 18, divide by 3. I get y is greater than or equal to negative 2/3 x plus 6. So here's my y-intercept. Rise over run is down 2 over 3. So there's that. We draw our line. Okay, so here's my line. And then I got to pick my test point. I get 0, 0, which is 2 times 0 is 0, plus 0. So this 0 is greater than or equal to 18, which is false. My test point was down there, and it was false. So that's on the side that is not true. So I would shade everything up here. And that's it. Okay, that's it. Let's go back and take a look here. We can, we can use a coordinate plane to solve inequalities with one variable also. For example, we could graph any of these because of what we know about Hooyvuks. So I could just graph those. If we have 3x plus 5 is less than 14, I would subtract 5 from both sides and then divide by 3, and I end up with x is less than 9. Well, I can put that on a coordinate plane. It's a dashed line, it's a vertical line, and it's everything to the left. Really simple as that, because less than is this way. If we look at these two, if we look at 3a, we have, first we want to solve for the x, so we have 4x is greater than or equal to 20, and x is greater than or equal to 5. So I go to 5, and I put a line. It's greater than or equal to, so my line is solid. Okay, so I go to 5, and I put a solid line right there. It's vertical because of Hooyvuks, I know that. And then it's greater than. It says greater than right there, so it's just everything on this side. Okay, that's it. If we were to do this one, go ahead and pause the video and try that one on your own. Go ahead and pause the video now and try that one. All right, you've unpaused. Let's take a look at what you got. We subtract 6 from both sides. We have negative 2x is greater than 6, and then x is less than negative 3. So we go over here, and at negative 3, I'm going to put a vertical line right there. Okay, and whoops, actually it's dashed because there's no equal to option, and then it's less than, so it's everything on the less than side of it. So it's all that over there. So that's 3b. This is 3a, and that's how we do those with the vertical line. Using inequalities to solve real-world problems, we should be used to this at this point. Everything we do, we're going to learn how to do it algebraically, and then we're going to say, all right, well, here's a word problem with that same exact kind of thing. This example walks us through a yearbook company, and it promised to give the junior class a picnic if they spend at least this. Each yearbook costs this, and each class ring costs that, and how many yearbooks and class rings must the junior class buy to get their picnic? Well, because could be a combination of the two things, there's all sorts of answers. And then you use a test point, you pick some answers, and you see where to shade, okay? Let's take a look down here. Neil wants to run a marathon at a pace of at least 6 miles per hour. Write a graph and an inequality for the miles y he will run in x hours, okay? So we'll try and set that up, write a graph and an inequality for the miles y he will run in 6 hours. Go ahead and pause the video right now and try to get an answer to that. Go ahead and pause the video. All right, so you've unpaused. Here's what I got. The inequality that I got is y is greater than or equal to 6x. If he's running 6 miles per hour, x is the time, so 6 miles per hour, and that'll give me the total distance that he ran. I changed my graph so that each one of these was worth 3. It doesn't quite get up to the 26.2 of a marathon, but it's close enough. So I go over 1 and he runs 6 miles, over 2 and he runs 12, over 3 and he runs that. So then all I have to do is pick a test point. I couldn't pick 0, 0 in this instance because it goes through 0, 0. So let's say I pick 1, 12, okay? So say I pick 1 and 12, 1 for that, 12 for this. So I get 12 is greater than or equal to 6, and that's true. So this is the side of the graph I would shade. I would only need quadrant 1 here because we're dealing with a real-world implication where there is no negative time and there are no negative miles, so we only needed that first quadrant, okay? That is it for the notes. What I would like for you to do is if you could practice, just try these 1 through 11, see how you do. The information for number 11, if you need that, is over here, by the way. I'll erase this because I just wrote all over it. But sometimes we don't see that. So try those, see how you do, have questions on those, and I will see you on Wednesday.